Here we have this question. It says, find the slope of the tangent line to the curve at the points specified. So the slope of the tangent line, what is the slope of the tangent line? Is it the same as saying the derivative? So what we want to take is differentiate the term we are given and evaluate that term at the given points. Remember, dy dx is the slope and it's the derivative. So let's differentiate this term first. So that's gonna be 2x and then plus 2y dy dx, and the derivative of a constant is just 0. And remember, this is an implicit function, that's why we have dy dx. Now I want to solve for dy dx, so I'm gonna move 2x to the other side and then divide both sides by 2y. So we'll end up minus x over y. Now the given points in the questions are as 0 and minus 1. So what I'm gonna do to find the slope at that point, we're gonna plug these values into the derivative. So this can be written as dy dx evaluated at 0 minus 1. I'm gonna be minus 0 over minus 1, and that should be 0. So what does that mean? This means the slope at this given point is 0, which means a slope at this point is horizontal. So this is a graph, a sketch. What does it look like? So the point is exactly at a peak or a minimum, and the derivative is just 0. So here at 2 we have sine xy equal to x, and we want to evaluate the derivative at 1 and y over 2. So we start to differentiate. This is a chain rule, but notice xy, we need to use the product rule to differentiate this term. This is what I'm going to do now. End up by y plus x dy over dx. Now I'm gonna take that function and plug it back into the derivative of the whole term. Get gonna be multiplied by y plus dy dx, and then the derivative of x is just 1. Now again I want to solve for dy dx, so I'm gonna move cosine xy to the other side by dividing both sides by cosine xy. Now I want to move y to the other side, so gonna be 1 over cosine xy minus y, and then I'm gonna move x, so I'm gonna divide both sides by x. And then what we have in here is this function. Now we are ready to evaluate that function at the given point 1 and pi over 2. So that's gonna be cosine of pi over 2 minus pi over 2 and all over 1. This is the same as 1 over cosine of pi over 2 minus pi over 2. So what we notice here, remember this is evaluated at the points. This is 1 over 0 minus pi over 2. 1 over 0 is infinity. It goes to infinity, or we can also call it it's undefined. So basically dy dx goes to infinity, which is the same thing as saying it's undefined at the point given, which is 1 and pi over 2. Therefore the slope at this point is vertical. It's not horizontal, it's vertical because it goes to infinity. And this is the same thing as saying the vertical, we have infinite slope. Here we have x cubed plus 2xy plus y squared equal to 4. We want to evaluate that at 1, 1. First, I notice the second term, when we differentiate that, we need to use the product rule. Therefore, I'm just applying the product rule in here. And then I'm gonna differentiate now the whole term. So gonna be 3x squared, and then the product rule, which is y plus x dy over dx, and then a plus 2y equal to 2y dy over dx and equal to 0. So each time, remember, each time we differentiate y, we have to write dy over dx. Now we want to solve for dy dx, so what I'm gonna do is move the term 3x squared to the other side. So now I'm gonna divide by 2. We'll end up by y plus x dy over dx plus y dy dx, and then minus 3 over 2 x squared. Now we can move the first term y to the other side, and then we can factor dy dx. I already factored dy dx, and here I already moved the y to the other side. Now we just divide by what's in front of dy dx, and that's dy dx. Now we want to evaluate that at the given point, which is 1, 1. So I'm gonna block x equal to 1 and y equal to 1, and this derivative, and then minus 3 over 2 minus 1 gonna be minus 3 over 2 minus 2 over 2, which is gonna be minus 5 over 2. So the top is gonna be minus 5 over 2, and then all over 2. Here 2 and 2 will be multiplied, so it's gonna be minus 5 over 4. This is the evaluated derivative at that point.